All right, example 2. At what point on the graph y equals 2 to the power of t minus 3 does the slope of the tangent line equal 21? So here I want to determine the point on that graph where the slope is equal to 21. Now there's something you need to remember, is that slope is the rate of change. And rate of change and slope both mean the derivative. So the derivative is the rate of change of something, so derivative is slope. So what we're going to want to do then is we're going to want to take the derivative of our function. So the slope is equal to 2t, 2 to the power of t minus 3, and we take the derivative. Now this time, we're taking the derivative with respect to t, not to x, because our variable is in t. So m, the slope, is going to be equal to 2t times ln of 2. That's the derivative of this. This whole thing is the derivative of this. And then the derivative of negative 3 is simply just 0. So we want to figure out where the slope is equal to 21. So what you do then is you set the whole thing equal to 21. You get 2t times ln of 2. That's the calculus part. Now comes the algebra part. So we got to think about how we're going to solve this. Well, our goal is to get t by itself. So I'm going to divide both sides by ln of 2. Again, this is dividing both sides by ln of 2. So now I have 2 to the power of t is equal to 21 divided by ln of 2. So using our log properties, we're going to take the ln of both sides in order to get that exponent down to the front. So here we get t ln of 2 equals, and here we're going to use our quotient property of ln's to get ln of 21 minus ln of the denominator, which is ln of 2. Now what we're going to do is we're going to divide both sides by ln of 2 to get t by itself. So we get t is equal to ln of 21 minus ln of 2, all divided by ln of 2. So what we're going to do now is we're going to use our calculator, and we're just going to type that in. So we go alpha y equals, and then n over d. That means numerator over denominator. And from there, we are going to type it in. So you go ln of 21 minus ln of 2. Make sure to close your parentheses. All divided by ln of 2. And we push enter. And that's going to give us 4.921. So t is equal to 4.921. And what we're going to do now is we're going to store this, because otherwise we'll have a rounding error. So you push store, and we need to pick a letter. I'm going to pick K. So you push alpha, and K is right here, and enter. So now if I type in the letter K, it's going to give me that number again. Okay, so that's our t value. To find our y value, we just have to plug the t value in. So the formula was 2t minus 3 So in the calculator, we're going to put 2k minus 3. So 2, the power button's right here above the division sign. Alpha k minus 3. And you get 27.2965 something. So 27.296. So that means our ordered pair is 4.921, comma 27.296. On the AP exam, you're always going to round to 3 decimal places. The AP exam does not care whether you round or truncate. Truncating means that if I have this, I just go 3 terms out and I stop. I don't round. I just look at the numbers. Okay, because normally we would round this up to 7, but the AP exam is okay if you truncate. All right, so now I want you to try this one on your own. Determine the point on the graph of y equals 3 to the power of t minus 2, where the tangent line is parallel to the line y equals 2t plus 1. So go ahead right now, take a second, and work that out. All right, good job. So if the tangent line is parallel, to this line right here, that means that the slope has to be equal to 2, because parallel lines have the same slope. So what we want to do is we want to figure out where m equals 2. Well, remember m is slope, which is the derivative. So what we want to do here is set the derivative equal to 2. So 3 to the t minus 2 d dx. So 2 is equal to 3 to the t ln of 3. So we're going to divide both sides by ln of 3. And we get 3 to the power of t is equal to 2 divided by ln of 3. Then to solve this, we're going to take ln of both sides. This t is going to come to the front. And we get t ln of 3 is equal to ln of 2 minus ln of 3. So then t is equal to ln of 2 minus ln of 3, all divided by ln of 3. Okay, so that's simply, we're just going to type that into our calculator. So you go alpha y equals, and then the first one, and ln of 2 minus ln of 3, all divided by ln of 3. And we get 0.5453 something. Okay, so t is about 0.545. Dot, dot, dot. We're going to store that as the letter k again. Now when you store something as the same letter, it overrides it. So I hit store, alpha, k, enter. So now my new k value is that decimal. So to find the y value, all we have to do is plug in k for our t value. So 3k minus 2, 3 to the power of k minus 2, and we get negative 0.1795. So then the answer for this one is going to be 0.545, comma negative 0.179. Again, truncating the value instead of rounding. And that's it. That's how you're going to take the derivatives of an exponential function in order to find the slopes of tangent lines, or the point on a curve where you have a certain slope.